we have some images here. And if you have ever inserted a photo into a document, you know how you're like trying to make it the right size? Well, hopefully you know by now that you don't want to pull from the side, because then you get this distorted, long, spread out image. And you don't want to pull that image from the bottom, because then you get this stretched out, long image here. If you want the picture to have the same proportions as your original, you always pull from the corner and spread it out that way. And then your photo will stay in the correct kind of dimensions, or proportions, I should say. So when you're looking at this, you can see that Godfrey and Kilroy are definitely not proportional to our buddy here. You can tell that this one was stretched to the side. It has the same height as Buddy, but its width is twice the width of Buddy's. Same thing with Kilroy. The width is the same as Buddy, but the height is twice of Buddy's. So the only two that would be considered proportional for these is Buddy and Dabney, okay? And you can put a box around this, or you can highlight this, but a scale factor is a positive number which multiplies some quantity, okay? And we're going to be working with scale factors over the next couple of days. Today is our hands-on experience with scale factors. But if you look at this, it says whose face represents Buddy's face multiplied by a scale factor of 2. So here's Buddy. If you multiply by a scale factor, every single dimension of Buddy will be multiplied by 2. So that means the mouth should now be 4. The height of the mouth right here was a half, and now it will be 1. So every single thing, every single dimension of Buddy's is going to get multiplied by 2. And so we can say that Dabney here represents Buddy's face multiplied by a scale factor of 2, okay? Now, scale factors can go both ways. You can enlarge and you can reduce. So if we look now at Dabney's face, it says, well, which of these images shows Dabney's face multiplied by a scale factor of a half? Well, that means that every single dimension of Dabney's gets multiplied by a half. So that means the width here was 8, and now it will be 4. The height was 8, now it will be 4. The height of this little triangle was 2, so now it's going to be 1. So we can say that Dabney's face multiplied by a scale factor of a half is Buddy's face. And I know we talked about it a lot too, but the ones that look the most alike are Buddy and Dabney. Okay. And the reason that they look alike is because all of their lengths are proportional to each other. So let's get kind of a hands-on experience with this. I'm going to turn the page and we're going to look at some arrows. Okay. We don't need to worry about this last column. We're not going to dip into the area of the arrow right now. Okay. We're just going to focus on the proportions for this. Now, scale factors can be written as a percent, a decimal, or fraction. So if you have a scale factor of 100%, then if we move the decimal place over 2 spaces, then we would say it has a scale factor of 1. So basically, it's staying the same. So you have your starting arrow, arrow 1. Now, if we multiply this starting arrow by a scale factor of 200%, that is the same as multiplying by a scale factor of 2. So what we're going to do is we're going to multiply every single dimension of this arrow by 2. And because this scale factor is greater than 100% or greater than 1, we can say this is an enlargement because it's getting bigger. And then we take our dimensions. The height of the rectangle here is 4. If we multiply by a scale factor of 2, then the new height is going to be 8 units. And you see the base of the triangle here is also 4 units. If we multiply by a scale factor of 2, this is going to be 8 units. Now's the fun part. We get to draw it. Okay. Well, some people might not think it's fun. I think it's fun. So I'm going to get a purple pen. Okay. Now, in our table, we talked about the height of that rectangle and the base of that triangle. But there's a lot of other dimensions that go into play here with the arrow, okay? So the first thing I'm going to notice is that my arrow is 2 units high. If we multiply that by a scale factor of 2, then we're going to want our arrow to be 4 units high in our new drawing. Okay, so that means the arrow is just the triangle part of the arrow is going to be 4 units high. And we already know that since it was 4 units in the original triangle, we multiply by a scale factor of 2, this is actually going to be 8 units now. So just the triangle portion is going to look like this. And every dimension has been multiplied by 2. So our height now is 4, the base of our triangle now is 8. Now let's take a look at the rectangle portion of the arrow. You can see that right now this little overhang thing right here is 1 unit. If we multiply by a scale factor of 2, then this should now be 2 units. So that means our rectangle is going to start here on both sides, because you want 2 units of an overhang here, 2 units of an overhang here. And because this was 2 units wide in the first arrow, now it's going to be 4 units wide, which makes sense. You can see it. 1, 2, 3, 4. And because it was 4 originally, it will now be 8. So I'm going to draw my 8 units. I think that's 8. Okay, so there's our new arrow. Okay, this is the same arrow here, but it's multiplied by a scale factor of 2. Okay, so this is going to be arrow number 2. This is our second arrow, and it is big. Okay. Okay. Now that we've done a scale factor of 2, we're going to do a scale factor of 50%. Now, when we switch 50% into a decimal and fraction, we get 0.5, or we can say 1/2. Okay, so 50% is the same as 0.5 and 1/2. So what we're going to do is we're going to take all the dimensions again from our original arrow, and we're going to be multiplying them by 0.5 to get the new dimensions. And since this percent is less than 100, we know that this arrow is going to be getting smaller. So we can call it a reduction. Okay. Now, if we multiply the height of the triangle, which is 4 units, by 0.5, the new height of the triangle is going to be 2 units. Okay. Base of the triangle was 4 units, so now it will also be 2 units. I recommend you do this in pencil, and why don't you try and see if you can sketch that now. And I'm going to walk around, and then we'll take a look at what it should look like. Take attendance real quick too. draw my little triangle on there so you guys can see how it compares. You really have to think about everything. So the height of my triangle here was 2. If I multiply that by 0.5, means my triangle now will only be 1 unit high. It was 4 units across, so now it'll be 2. So just the triangle of my arrow is going to be pretty teeny tiny up here. And if you think that's small, wait till we get to the 25%. That's itty bitty. Okay, now the width, the overhang here, you have to consider that. It was 1 unit on the original, and so if we multiply that by 0.5, that means the overhang part should just be like 0.5 or a half of a unit. So that means I'm going to be starting kind of like in between the lines here. And we know that the 4 times 0.5 is going to be 2. Okay, there you go. This is what it should look like. Okay, it's the rectangle's 2 units by 1 unit. Your triangle has a base of 2, height of 1. And sometimes you're not going to be right on those grid lines. Sometimes you have to go between them because your arrow is so small. Okay. Okay, I'm going to go through one more with you fully, and then I'll have you try the 25 and the 25% and the 125% on your own. Okay, so let's do this one together though. As a decimal, 150% is 1.5 or 1.5. Because it's above 100%, this is going to be an enlargement. The height, so we're basically gonna multiply 4 units by 1.5. So this will be 6 units and 6 units. Okay. All right, now remember that you have to consider the other dimensions too, because the height of the triangle here was 2. If we multiply that by 1.5, then the new height of our triangle should be 3, because 2 times 1.5 is 3. And we know the base of our triangle is 6, so I'm going to put my dots there just to guide me. Okay. Now I know that this is 2 wide here, so that means this one's going to be 3 wide, but I'm going to focus on my little overhangs first. This was 1 unit. If we multiply 1 by 1.5, then that means that this overhang should be 1.5 or 1.5 units on both sides. And if I look at this, this is a half, 1.5, 2.5, 3. So even though you go between the lines, it's still 3 wide like it's supposed to be. And we already know that it's going to be 6 units tall. We call all of these figures that are the same proportionally, we call them similar figures. This is arrow number 4. Okay. One of my R's is hard to see. There we go. Okay. So what I want you to do is I want you to try, these are tricky, but go ahead and see if you can do these arrow 5 and arrow 6 on your own, and we'll go over it together in a couple minutes. Okay, let's go ahead and talk about these real quick. Well, we know that number 5 is definitely a reduction. It is teeny tiny. And number 6 is an enlargement. With your arrow number 5, you can see that the height of the original was 2, and if we multiply that by 1/4, you should only have it halfway. Okay, so your little itty bitty arrow, the triangle should be a base of 1, and the height of that triangle should be 1/2. And then the width was 2 before, so now it's going to be 1/2, and the height of that rectangle should be 1. Okay. And then for this one right here, a scale factor of 125% or 1.25 means that your 4 units before will become 5 units now. So the base of my triangle is 5, the height of my rectangle is 5. Now the height of the triangle here was 2, and if I multiply 2 times 1.25, I get 2.5. So my triangle here, the height should be 2.5, and the width should also be 2.5, which is kind of hard to see that it's 2.5 here, but the little overhang, which was 1, is now 1.25. This overhang is 1.25, which means that this is 3/4, 1 3/4, 2.5. Okay, so that's what that looks like. So tonight for practice, and even you might even be able to get some of it done now, you are going to do the square page. Okay, squares are a little bit easier, so don't worry about the area box, but go ahead and fill all this in and do your scale drawings of your squares. Okay.